Hello everyone, my name is John Ranjiran Piancheta, and today we're going to be talking about the different types of atomic models and its histories and theories and creators throughout the years. So without further ado, let's get right into the video. So the first model we're going to be looking at is John Dalton's solid sphere model, or some call it the billiard ball model. In 1803, Dalton John Dalton drew upon the ancient Greek idea of atoms. The word atom comes from the Greek word atomos, meaning indivisible. His theory stated that atoms are indivisible, those of a given element are identical, and compounds are combinations of different types of atoms. And in this model, he showed that he can be recognized atoms that are of a particular element will be different from other elements, but the problem is that other atoms, or all of the atoms, are not actually indivisible. They're actually composed from subatomic particles. So what it would look like is model. So according to him, that the model would just be like a particle, like a small sphere, like type. That's what he was going for. The next one that we're gonna be looking at will be J.J. Thomson's plum pudding model. So in 1904, Thomson discovered electrons, which he called corpuscles in atoms in 1897, for which he won a Nobel Peace Prize. He subsequently produced the plum pudding model of the atom, and it shows that the atom is composed of electrons scattered throughout a spherical cloud of positive charge. This recognized the appearances of electrons and the components as electrons as a component of atoms. The problem is, though, with this model, that it didn't show any nucleus, which will be clear to us in the next model. There wasn't a nucleus that was clear into the plum pudding model, and this will be explained later on. The reason why it's called the plum pudding model, it's because when you look at his model, it's like a plum pudding. How the electrons are scattered throughout the spherical shape of the model. The next one is the nuclear model by Ernest Rutherford in 1911. Rutherford fired positively charged alpha particles at a thin sheet of gold foil. Most passed through with little deflection, but some deflected at large angles. This was only possible if the atom was mostly empty space, with a positive charge concentrated in the center, being the nucleus. This realized the positive charge was located in the nucleus of an atom. This showed us that the positive charges, the negative charges, will be always located in the positive charge rather, only, will be located in the middle or the center, which is where the nucleus is. But this didn't explain why there were floating or uh, revolving negative particles around the nucleus. Uh, in that case, we were shown that these are in open space and that the center is the nucleus. What that would look like is, for example, let's say I have the nucleus here, and these are the negatively charged atoms, particles, that will go around the negative charged electrons going around the nucleus as if it's like a planet or going around the sun. So it's also called the planetary model because of its resemblance of the planets revolving around a sun. That's why it's called the planetary model. The next one is the Neil Bohr's model. So this is also called the planetary model because it is also revolving the negative particles, the negative electrons, or around the nucleus. So Bohr modified Rutherford's model. So like we said, like they shared some similarities And Bohr here only modified the original model given by Rutherford, and that the uh, model of Ernest Rutherford, where the atoms were uh, revolving around the nucleus in orbits of fixed sizes, and electron energy in this model was quantized. So in the next one is he proposed that stable electron orbits, and that he explained that the emission of the spectra of some elements. The problem is though that the moving electrons weren't able to show why this was happening, and it would just look like that the electrons weren't being stable because when you were given a model like Neil Bohr's, it were the electrons should have just uh, hit the nucleus in the center, which would make it collapse and making the entire model unstable. Lastly, we have Erwin Schrödinger. In 1926, Schrödinger stated that electrons do not move in set paths around the nucleus, but in waves. It is impossible to know the exact location of the electrons, but instead we have clouds of probability called orbitals. And orbitals are the area in which we are more likely to find an electron. This shows that electrons don't move around in a orbit within the nucleus that we were shown in the last two models, and then it shows that electrons are more widespread. And as we can see here, that this model is still widely accepted as the most accurate model of the atom, as it explains everything on the atom. What it would look like would just be like this in more of a cloud form. It's a spherically cloud form of mass with the nucleus being in the center as always. And pretty much that's it. That's the history of the atomic models and its theories and reasons why they were come to be. This has been John Ranjiran Piancheta, and thank you for watching.